Hi, I'm Richard Balsley with Microsoft, and today we're going to go over how to reimage Windows fast with full flash update. So the full flash update process that we've developed here includes really two pieces. There's the first piece of building the FFU file itself, and then there's the deployment of the FFU, which leverages USB drives. And so when we build the FFU, what we're going to start with here is a quick start process. We're going to show you how to quickly get started with the prerequisites and sample command just to get you up and running. We won't spend a whole lot of time going over exactly how the script works. We'll just go through and get you going. But later on in this presentation, we'll then go through all the different parameters that the script uses. Throughout the presentation, we'll start talking about all the different parameters, but there's some important ones that you need to understand how they affect the script and its execution. We'll then go over Windows Media, talking about both business and consumer media, the importance of each, and how to handle each of those. We'll then go over applications and how you can bring your own applications, or you can leverage Winget to automatically download applications to include in the building of the FFU. We'll then go over drivers. And again, similar to applications, you can bring your own drivers. However, we can also automate the download of drivers from the 4 main OEMs. Then there's also the customization of the deployment USB drive. And with that comes multi-model driver support. So when you build your FFU, you can add drivers to the FFU itself, but then you can also leverage the USB drive to copy drivers to the USB drive that will then be injected in real time as you're applying the FFU to a machine. And so what this allows you to do is effectively pick, if you're imaging a specific model, you can pick from a list of drivers that have been added to the USB drive. You can say, okay, there's 10 folders in here of all these different models. I want to select one of those to copy the drivers into the FFU that I'm currently laying down on the machine. And then we also have device naming. And so we'll talk about how to leverage device naming to make the device naming experience a bit better. Because right now with device naming, with Autopilot and with provisioning packages, a reboot must take place in order to name the device. We can actually omit that reboot and prevent that from happening at all if we name the device before we get into the out-of-box experience. And so we'll talk about how that works. And then lastly, actually two more things. Device enrollment, so leveraging provisioning packages or Autopilot for existing devices. We'll talk a lot about Autopilot for existing devices. And then there's also normal Autopilot that you can also leverage. That works too. And then custom WinRE support. So if you have a custom WinRE, you might have drivers or maybe other utilities that you include in your Windows recovery environment. You can bring that as well if you want to have that. Okay, so for a quick start, we need to go over the prerequisites. So the first prerequisite is you want to have a machine that's either running Windows 10 or Windows 11. I should have also put server here. You can use server as well. So if you want to use server 2019, 2022, those are options as well. You'll then want to install Hyper-V. Hyper-V is going to be needed because we create a VM if you are going to be adding applications. So if you're going to add Office or any third-party apps, then you need Hyper-V in order for that to install those apps. And then once you have Hyper-V installed, we then need to configure a Hyper-V switch. And so this can be an external or an internal switch. I personally use external. You can use internal. I've tested both. Both work fine. You just want to make sure that you're getting the IP address of the switch. So you'll need to run ipconfig/all, go find what the IP address is of the switch that you have just created. You then want to download the latest release of the FFU build. And so at the URL that you see on the screen here, the latest release is 2407.2. Go ahead and download that, and then extract out of that zip file. There's an FFU development folder. Extract that to your C FFU development folder. And then we have our USB drive. So we want to make sure that we're using USB 3 drives. It'd be 3.0, 3.1, 3.2, doesn't really matter. The script is set up right now to work with removable drives. However, if you have an external drive, there is a build in 2408.1, we've added support for external drives. Some USB sticks, you might think it's just a removable USB stick. Some of those actually get flagged as external hard disk media. And so the script doesn't handle that today with 2407.2. It does handle it though with 2408.1. Now drivers, you'll need to download your own drivers. If you're going to use the quick start process, we don't go through and download make model. We'll do that later at the end of the presentation. But for the quick start process, you will need to bring your own drivers. And you can just go ahead and you probably have a cab file or a folder somewhere that has the drivers of a model that you're trying to image or test with. Go ahead and just go download those drivers and put them into the C FFU development drivers folder. Now to run the script, we are going to run the script, and when we run the script, the command that we're going to use is going to download Windows 11 Pro x64 Media in English. We do this from the Media Creation tool. We will then download the Windows cumulative update, the latest cumulative update for Windows. We will download the .NET cumulative update as well. We will download Defender and both its platform and definition updates. We'll download Edge, OneDrive. We'll configure OneDrive for per machine install. And then we'll also download Office, the latest release of the current channel of Office or M365 apps. And then we'll also copy your drivers. If you put any of the drivers in the C FFU development /drivers folder, we'll copy whatever drivers are in that folder. And this process can take up to 40 minutes to create the FFU. I mean, a lot of this is just due to that we're downloading a lot of stuff, but we're also going to put the cumulative update into the build of Windows that we're downloading from the Media Creation tool. And that is really what takes the most time because the Media Creation tool media is somewhat old and the cumulative update is somewhat big. And so when you combine those two things, it's just going to take some time to process. So the command we're going to use is what you see on screen here. This command will be in the comment section or in the description of the YouTube video. And so this is exactly what we'll use. So let's go and let's go over to the VM and let's get started. Okay, so in the VM we have our quick start VM that we've set up, and it is running Windows 11 Pro. And the first thing we want to do is make sure that Hyper-V is installed. So if we go, just type in hyper-v. It's not installed yet, so we need to go and install it. So just click on Hyper-V, click OK, and then this will need to reboot, so we'll let this do its thing. Okay, so Hyper-V should be done installing. Yep, so we have Hyper-V Manager here. Now the next thing we want to do is we want to create a virtual switch. So if we go to Virtual Switch Manager, and we'll just create a new external switch. I'm just going to give this the name of external, and then hit apply. Okay, so we have our switch, and now we need to get the IP address of that switch. So if we open up terminal, we'll go to ipconfig/all, and we're looking for our switch, which is external, and we will see that we have a address here. This is going to be important. I'm going to take the name of the switch and the IP address, and we'll need to put it in our command line. Now before we do that, we need to go download all of our files. So let's open up Edge. We will not sync data. Let's get through all this stuff. Okay. So we'll click this link for 2407.2, download this. And then we just want to copy out, so just Control-C, copy this folder out, put it on your C drive. Okay, so this has everything we're going to need. Now, because I'm running a VM, I won't be attaching a USB drive, so I'm not going to actually build the USB drive in this process. But you will want to plug a USB stick in, so that way it'll create the USB media. And then you'll also want to copy in your drivers. Now, because I'm building this all through VMs, I'm not going to have any drivers here, but if I did, I would copy in a folder here. This might be for a specific model. Let's just say it's like a Lenovo 500W. So I would copy in my drivers into this folder, and then when the script goes and detects the drivers folder, it'll go ahead and copy in and recurse through the Lenovo 500 folder and copy everything into the FFU. And so with that, let's get started here. So I'm going to grab the command, and let's go back into terminal here. Actually, let's make another terminal. Yes, I could use tabs at the top, but I'm old school. All right, so we're in our CFFU development folder, and what I'm going to do is I'm going to paste in the code, and we're going to get an error message here because it's trying to run it because there's a return character somewhere in there, so it's trying to execute it, but it's not going to work because we need to let scripts run on this system. And so this is a brand new VM, so we haven't turned that on yet. So we need to run set execution policy. Execution policy. I'm just going to do unrestricted. You can do bypass, completely up to you. This is not what security best practice would say. Don't do this. I'm not recommending doing this. I'm just doing this because I need to get this thing to run. But you can probably set bypass or do whatever your security department requires you to do when it comes to running PowerShell scripts. So next thing we want to do is modify our command. So I'm going to modify a few different things here. The first thing I'm going to modify is I'm going to actually turn off drivers because I'm not going to include a drivers folder. If you don't do this and you run it and there's no drivers in that folder, it will give you an error message. So we do check to make sure that you have drivers in the folder. The next thing I'm going to do is modify the VM switch name. And so in here, we're going to do external. And then for my host IP address, that's what we saw in the other window, and that's why I kept the other window up. It should be 183, which it is. So .168.1.83. Okay. And then we wanted to create deployment media. We wanted to create USB. Well, I don't want to create a USB drive. You do. Don't remove that. Keep that for yours. Plug in a USB drive. Let it build the USB media. I'm not going to do that though because I'm in a VM and my USB drives don't show up in my Hyper-V VM. So we won't do that. We will then update the latest CU. We'll update the latest .NET. We'll update the latest Defender, and then we'll update Edge and OneDrive. And so let's kick this off, make sure it gets started and goes. Okay, so this is going to do a lot of things. It's going to download ADK, it's going to install the ADK, it's going to install the Windows PE add-on, and it's going to download Windows and a whole bunch of things. This is going to take probably about 40 minutes. You can sit and watch it if this is your first time doing this. Sit and watch, check it out, make sure it's doing what you expect it to do. You can watch the verbose output on screen. There's also a log file you can take a look at. So if you go to your FFU development folder, there's a log file here. You can open it up with cmtrace if you want. If you're using Config Manager and you have the cmtrace tool, you can open that up and just kind of watch it in real time. You can watch the verbose. The output should be very similar. It's going to be slightly different, but for the most part, most of the stuff that you see in the verbose output will be in the log file. So you can watch it that way. I'm going to come back at the end of this. We're going to wait for this to all complete, and then I'll come back at the end and we'll just talk about what we've seen here. But this is meant to be a quick start. It's not meant to be something that we go through and explain everything, how that works. That's what the remainder of the presentation is going to be. Okay, so let's talk about parameters next. Now for parameters, there's a section in the FFU development docs/build deploy FFU.docx file. That's the manual for this whole process. It's fairly long. There's a lot of information in there, but there's a section in there called script parameters, and that documents every single parameter that we use in the process. Now, as we go through this presentation, we'll go over the various parameters and their use cases depending on the scenario. So as we start to build media, there are different parameters that are leveraged in the build of the Windows media. So instead of just going through every single parameter one by one, depending on what we're doing, like applications, there's a bunch of different parameters that control how applications are deployed. As we go through those sections, we'll go through the parameters that are relevant to that section. Now, the install apps parameter is probably the most important parameter, only because this is how it controls whether a Hyper-V VM gets created or not. And if this is set to true, then a VM is created. But the next set of equally important parameters are the VM switch name and the VM host IP address. And so in the quick start, you saw how I went and got those parameters, or I got the data for those parameters. I created the switch, I went into ipconfig /all, and I got the name of my VM switch and the VM host IP address. Again, those two things are important so that we can copy the FFU file back to the host machine from the VM. Now, there's also a variable called ISO path. And ISO path allows you to bring your own ISO, and we'll talk more about this as we go through the Windows media. But if you don't define ISO path, then what happens is we actually go out and we download your Windows media from the media creation tool, this using the same process that it uses. And so if you don't define an ISO path, we're just automatically going to go download Windows media. And when we do that, we set install apps to true. And the reason we do this is because there's an issue with applying ESD files to VHDX files. I haven't figured out why that is, but I've just noticed that if I just try to apply a ESD directly to a VHDX, what I've noticed is that it tends to fail when I try to boot from that VHDX and try to capture that into an FFU. So instead of that, we do boot from the VHDX into the VM, and then we just create the VM, and we just capture basically a vanilla installation of Windows with no customizations whatsoever. If you aren't installing any applications or Office or anything like that, we just use just a vanilla stock installation of Windows. So that's what happens if you don't install any apps, but you want to just use an ESD. Okay, so let's talk about Windows Media. So media comes in two types. It comes as business media or consumer media. And the media can be obtained from a couple different places. So we can go to the Volume Licensing Center. So if you go to VLSC, which has been moved to admin.microsoft.com now, you can go there and you can download business media. You can't download consumer media from VLSC. You can only download business media. The next place to download is from Visual Studio Downloads. So if you have a Visual Studio subscription, and you have access to media within that subscription, you can download business or consumer media. And that's where I get my media. If I want to get the latest build of Windows that has the latest cumulative update, I'll go to Visual Studio Downloads and I'll download that media. Then you can also use Media Creation Tool. And that's what the tool itself, that's what the script is using. It's going out and looking at where Media Creation Tool gets its media from, and we go and we basically use the same kind of process. And that media is consumer media. Now, if you want to leverage subscription activation, then you must use consumer media. Now, why do you need to do this? Well, OEM media is based on consumer media. And the key that they put in the firmware of your device is consumer. And that key is what's used to activate the machine. It's not subscription activation. Subscription activation, the name of the service, is not really what is actually being done. Subscription activation will step up the device to enterprise or education, but it will not activate the device. The activation is done through just basic Windows processing. As Windows boots into the out-of-box experience and gets connected to the internet, it activates during that time. As you start to go through all the windows of the out-of-box experience, all the different screens, it's activated in the background. So by the time you get to the desktop, your machine's already activated because it looks at the firmware key and the activation service processes what key is in the firmware. So subscription activation then just does a step up from Pro to Enterprise. Or if you're using Pro Education as your media, then you go from Pro Education to the Education SKU. That's what subscription activation is doing. Now, if you reimage with business media, and don't provide a product key, then activation is going to fail, but the step up to enterprise succeeds. So imagine if you download business media from volume licensing, because that's the only place you have access to media, and you don't want to use the built-in process that the script uses to download the media from the media creation tool. If you decide to go and just use your own business media, but you don't use the dash product key parameter and pass a product key, then activation is going to fail because you're using mismatched media. That media does not match the media of the key that's in the firmware. So if you want to use business media, you want to use ISO path and use the path to your ISO file. And you want to use product key and then put the product key in. Now the product key can be the KMS general volume licensing key, the GVLK, or the product key can be a KMS or not a MAC or any other type of key that you might have access to. Okay, so now how do we obtain the media through the scripts? So the script leverages media creation tool, like I mentioned earlier, to download an ESD file. Now you can use the following parameters, and so we're going to have a table here that's going to show up in a second, but the following parameters to control what media gets downloaded. But note that the 23H2 media from the media creation tool is about 7 months old. So if you use update latest CU and set that to true, the script will download the latest CU and service the media. But as I mentioned, the latest cumulative update is from July 2024, but the media creation tool is 7 months old. So what can happen, or what will happen when you do this, is that it's just going to take a little longer to add the cumulative update to the older media. That's it. So it might add, about 13 minutes. That's the timing that I've noticed. It's about 13 minutes right now of additional time for it to add the CU to the FFU, or I'm sorry, the CU to the 23H2 Windows 11 media. So just keep that in mind. So these are the different parameters that control what media gets downloaded through the media creation tool process that the script uses. So the first thing is that you can pass the SKU, and that's a string parameter, and that allows you to pass in home, home N, home SL. You can see all the different SKUs that are on the screen here, but we default to Pro, because that's what most people are going to use is Pro. But there are other types of SKUs that you can use if you're in a different region or different area, or you just have something that's unique to you. These are the different SKUs that you're able to download. Now the Windows release parameter is an integer parameter that's a value of 10 or 11. And this is used to identify which release of Windows to download. And by default, we're going to download Windows 11. But you can change this to 10 if you want. Next is Windows version. So the Windows version is a string, and that's string value of Windows to download. This is used to identify which version of Windows to download from the media creation tool. We actually also use it when we download drivers for HP, and we'll talk more about that later. But the default is to download the 23H2 media. Now for Windows architecture or Windows Arch, that's a string value of x86, x64, or ARM64. It only supports those three values. And this is used to identify which architecture of Windows to download. The default is x64. We've just recently added ARM64 support, so we can download ARM64 media as well. When you do download ARM64 media, you need to actually be building everything from an ARM64 based machine. So if you're using a Copilot PC that has an ARM64 processor, you can build a FFU for ARM64. If you're trying to do this from an x64 machine and trying to build ARM64 media, you can't do that. It won't work because we have to match the architecture of what's on the host machine. Now for Windows language, you can pass a string value in language region format. So in this case, English US would be EN-US. And this is used to identify which language of media to download. The default is EN-US. The build deploy FFU.doc file has a list of all the different supported languages. And then for media type, that's a string, and that can either be business or consumer media. This is used to identify which media type to download. The default is consumer. So I actually made a mistake on the prior slide. I did mention that media creation tool is only consumer. You actually can download business media from it. I don't download business media from it. I only do consumer just because I use subscription activation for all of my activation to allow the step up, because that's what most customers should be doing. But if you do want to download business media from that, you can. I just don't typically do it. Okay. Bring in your own media. So this is what I would recommend you do, is if you can get access to consumer media and you're using subscription activation, use the ISO path parameter, download your own ISO, because it's going to make things a little bit quicker, because you don't have to download a cumulative update and apply it. But if you're lazy, you don't want to download media, whatever, then you don't need to do this. So if you want to save a lot of time, download the most up-to-date ISO from Volume Licensing or from Visual Studio Downloads. Latest ISO is published on the third Tuesday of every month. And then set the update latest CU to false, because you don't need to download the latest CU, because you have the latest CU inside of your media. Now, depending on how old your ISO is, it can take about 10 minutes to service. Like I said, it's about 13 minutes is what I just recently looked at to apply the latest CU to your media. So if you want to save yourself about 13 minutes, download the latest ISO with the latest media, with the latest cumulative update. Now the parameters to do this, ISO path, product key, I mentioned both of these earlier. They should be fairly self-explanatory. You can read on the screen here what they do. Okay, applications. So for applications, Microsoft 365 apps and Winget have been integrated into this process. And the whole point of this is to automate as much of this as we can. And so we automate the download and installation of apps into the FFU. It's not so much just building an FFU with no apps in it. Like the whole point of this is to put apps in it and make a thick image. I'm not going to sit here and argue about thick versus thin images, the benefits, the differences, hybrid. There's all sorts of different schools of thought on this process. But what we found for the situations that this worked well in, integrating everything into one big FFU and then deploying that out is definitely the fastest way that you're going to get Windows onto a machine. Now you can also bring your own apps that aren't available via Winget. So if you've tried looking for something in Winget, you don't see it there, or if you have a licensed application that has a specific license file and it's never going to be in Winget or in the store, then you can always just download and bring your own apps. Okay, so for Office, the way that we handle this in the process is that there's a folder called CFFU development /apps, or /apps rather. And inside that folder, there's an Office folder. And that Office folder contains two files. There's a deploy FFU.xml and there's a download FFU.xml. Now, if -install Office and -install apps are both set to true, then the script will download the M365 Apps Office to the Office folder under Apps, and it'll leverage the latest build of Office and the Office Deployment Toolkit. We will download the latest current channel release of Office via the ODT. So you shouldn't need to modify the download FFU.xml file. This will download whatever you need. However, you probably will want to modify the deploy FFU XML file, because by default, it's going to install Word, Excel, OneNote, and PowerPoint. If you want to include other apps, you can remove their exclusions from the deploy FFU.xml or replace it with one of your own. If you are going to replace it, make sure you're actually replacing it. Don't name it something different, because the script is looking for deploy FFU.xml. And if you have a different XML in there and you want it to use that, if it's not named the same, then the script isn't going to know and it's not going to be able to use it. So this is what the default file looks like. You can see that we're installing the Office Client Edition of 64-bit. We're installing the current channel, and then we're excluding Access, Link, Publisher, Bing, Teams, and Outlook. And so if you need Outlook, and if you Teams now doesn't seem to install through the ODT. It used to. I think with the stuff that's going on with the EU, and we're decoupling Teams and Office, I think that process is probably broken now. At least it seems to be. So if you want to include Outlook in this case, then you would remove the exclude app ID for Outlook. If you want to include Publisher or Link or whatever, I don't know why you want to include Link, but you can just exclude those if you want. And then if you wanted to modify any of the additional properties, like if you wanted to use device-based licensing, for instance, you could turn that into a 1, and so you can modify the ODT configuration if you need to. Okay, so for Winget, Winget support was added just this month for 2407, and it is controlled by the InstallApps parameter being set to true, and there's an applist.json file that needs to exist in the apps folder under the FFU development path. Now we provide you two sample files. We give you an app list underscore inbox apps sample.json and an app list underscore sample.json. The inbox apps sample.json has a list of all the apps that are installed by Windows by default and are searchable via Winget search app ID. So not every single inbox app is actually in Winget. So we've tried to add as many of them as we can, and the whole reason we did this and put that in the JSON is because store apps actually take quite a bit of, or I'm sorry, I should say inbox apps that are UWP apps. Those apps, there's a lot of them, and they take up a lot of bandwidth. And you'll see here in a minute how much bandwidth we save by actually doing this. Now, the sample.json has just the company portal and new teams. Now, you can create whatever applist.json file you want with all the different apps that you want to include. That's your prerogative. We've just given you a couple of sample files here to show what's possible. So by using the latest updated ISO in July of 2024 and installing the latest .NET, Defender, Edge, OneDrive, and all of the apps that are in that inbox apps sample.json file, we achieved a 70% bandwidth savings against just a stock, the latest July 2024 ISO with no additional updates to it. And so what that looks like here is that in this table, on the left, we've got our July 2024 Windows 11 23H2 stock ISO captured as an FFU. So this was a 7.5 gig FFU when the capture was completed. It was installed to a VM. All we did was capture. We sysprepped it, we captured it as an FFU, and then we redeployed it later. And when we did that, we found that the total data usage before updating store apps. So this is just signing in, getting to settings, looking at the network. Underneath there's a data usage area that you can look at to see how much data usage Windows used. And what we noticed is that it was about 261 megs when we did that. So then the next thing was, okay, let's go update the store apps and see how much data usage jumps to. And so we did that, and it was 1.82 gigs. Huge amount of difference there. It's about 1.6, 1.5, 1.6 gigs. Just store apps, just UWP apps that are inbox with the quote-unquote most up-to-date ISO. And then when you update Windows Update, 2.09 gigs. So this would include the malicious software removal tool. There's always going to be a Windows definition update for Defender. And so installing those additional things got us up to about 2.09 gigs. But when we included all of the stuff that I mentioned earlier with .NET, Defender, Edge, OneDrive, all the apps from the inbox app sample JSON, there's about 40 of them. When we did that, the first thing we noticed was that when we looked at the total data usage before updating store apps, it was 13 megs. Huge difference from 261 megs. But then when we went and updated store apps, we go from 13 megs to 558 megs. Still a huge difference from 1.82 gigs. Massive difference. And then when we look at after updating Windows Update, we go from 558 to 646. So if you compare 646 to 2.09, it's about a 70% bandwidth savings. All up. So a huge difference in bandwidth savings. And so for those of you that have well-connected internet connections and you don't care about this stuff, that's fine. But we have a lot of customers, especially in the education space, that are in rural areas that don't have great bandwidth. If you think about countries like India, you think they've got so many different rural areas that they just don't have the bandwidth to go for every single endpoint to go download content. And so we have tools like delivery optimization that they can take advantage of. There's a number of other third-party tools out there to help with bandwidth savings. But by and large, if you were to use something like this, going from 2.09 gigs to 646 megs, huge difference that they can take advantage of. And on top of that, you can also still use delivery optimization and those other utilities. And so this would actually just make the whole experience much, much better for the end user. So for Winget, what we do here is the way that the sample JSON file needs to be configured. You can see on screen here that we have this apps sample JSON. It's got company portal, it's got teams, and all you need to do for whatever application you want to include is open up your PowerShell command prompt, whatever, type in Winget search, and then whatever it is that you want to install. And that will give you the output of the name, the ID, and the source. We don't need version, but just take the name, ID, and source and just put it into the JSON file, as you can see on the screen here. This will make it so that we'll download via Winget these applications. Okay, bring your own apps. So to bring your own apps, all you want to do is create a folder underneath the FFU development /apps directory, make a folder in there, and then copy all of your installer files. And then you want to modify underneath that apps directory, there's an InstallAppsAndSysprep.cmd file. You want to modify that file with your silent install command. So as an example here, if we wanted to include Chrome, we can make a folder called Chrome. We can put the MSI file for Chrome inside of that folder. Then what we would want to do is we want to modify the InstallAppsAndSysprep.cmd file and add a remark for what it is. So in this case, we added a REM for Google Chrome, and then we put the MSI command line. Now, what you see on screen here for the InstallAppsAndSysprep file, it looks a lot different today than when this screenshot was taken. We're going to see in a bit here what the existing or what the current InstallAppsAndSysprep.cmd file looks like. So what this file does is it actually controls the automation in audit mode within the VM for what gets installed. And you are free to edit the file. However, you should add any additions below the rem add additional apps below here line, but before the set install store apps equals false line. Unless you know exactly what you're doing, because there's a lot of stuff that's kind of going on inside of this file. And so you want to make sure that you're adding your additional apps in the right place, so you're not impacting any of the other things that are going on. Now, if you have things that you manually need to add to the image, I know some customers like to customize the look and feel. And so there's just things that either they don't know how to automate or they just can't automate it. And if that's the case, you can add a pause to the file. You can add this anywhere you like. Sometimes I'll add it to the first line just so I can get the VM to stop right away. And then if I want to monitor what it's doing, or if I need to troubleshoot something, I can just hit enter or hit the spacebar on the keyboard, and then it'll start doing everything that's in the CMD file. And so I can watch it at that point, because it takes a while to just get to the VM if I'm installing all these different things. So a pause can be helpful. Now the apps folder, that actually gets created and put into an Apps.iso file. That Apps.iso file gets created, and then that is what's mounted to the VM. So what this file looks like today is that we have a lot more that's going into the file now. And so you can see, where we have that red box, it shows the rem Contoso app example and then rem MSI exec. If you want to just replace that, or just below that, add in your own applications and things you want to install, that's the spot you want to do it. Line 12, line 13, just do it all before line 14. Because afterwards, after all of that, that's where we start. If you have Winget apps that you're adding that are store apps or UWP apps, those application installations, they install differently than anything else. And so there's a process that we have to go through for dependencies and all this other stuff. So you'll want to make sure that you're not adding things or messing with any of that code that's there. Okay, so let's demo the app configuration for the FFU process. So as you can see, we've talked already about the Office folder, and inside of that folder we have our deploy FFU, download FFU. These are both XML files. Doesn't say it here, but if we had file extension support turned on, we would see that those are just two XML files. And then we also have our JSON files that I mentioned earlier, and then we have the InstallAppsAndSysprep.cmd file. Now, what I want to do is I want to add my own app. So in this case, what I'm going to do is I'm going to add Chrome. So if I make a new folder, and just like I showed in the screenshots earlier, you make a Chrome folder, and then you'd put the MSI to Chrome. So if we'll go download Chrome, download enterprise. Let's go download the enterprise file for Chrome. stable. That all looks good. So let's open the zip, grab the installer, and then go into the Chrome folder. So we've got the MSI installer, and now what we want to do is we want to reference it in the InstallAppsAndSysprep file. So if we go and edit this file, it's all right. I'm just running it. And where we want to make the edit is below this line. Now, you can delete this if you want. You don't need to have this here. So you can either delete that or just add the new line. And so here what I'm going to do is I'm going to call this Google Chrome, and then I'm just going to do MSI exec /I, and it's going to be Chrome. And then actually I'll just copy the file name. It's easier to copy the path. I'd rather just do this. Google Chrome standalone enterprise x64.msi, and then /qn/no restart. And then I would do this for any other applications I want. So I could have as many apps as I want, just make new folders for them, and then you'll want to reference D, and then whatever folder name, and then the file name. And you can use EXEs, you can use MSIs, doesn't really matter. You can even have PowerShell scripts if you want. I've got PowerShell scripts that I use and I deploy them. You would just need to make sure that whatever command line you're putting in here, you're using the silent installation command. We don't want to have any prompts for user input. Now you can do that though. You can go through and interact with this. So if there is something where you can't install something silently for whatever reason, then you can use the interactive installation methods. But ideally, everything you would do is just going to be a silent installation command, so you aren't prompted to do anything. And so you can kick this off and walk away, and then within half an hour, 40 minutes, everything should all just be installed. So that's the bring your own app scenario. Now I'm going to close this, and the file is not saved, so I'm not saving that file. I'm not actually going to keep this in my build. But the next thing we want to do is look at Winget, because Winget, I can get Chrome just like I did bringing my own app, but I can have Winget download the files and do that automatically for me, so I don't have to go and download and type in a command line and all that. So how do we do that? Well, as I showed in the previous slides, we use Winget, search, and then Google Chrome. And this will show me that I've got a bunch of different Google Chrome options that are available to me. Now what you'll notice in here is that we have the name, we have the ID, and then we have the version numbers. And the version numbers are obviously going to be different depending on the channel that you're in. So Google has Google Chrome, this one here, and then Google.Chrome, and then it's 127.0.6553 or 6533.73, and these are both the same. And this is the stable release of Chrome, and it's coming from the Winget source. Notice that there's not an MS source or an MS store source. There's just a Winget source. So what we want to use is we want to use this one. We want to use the second one here. Could we use the exe? Yeah, we probably could use the exe as well. I'm betting, though, that this one, I haven't done this, but my guess is that this is probably the MSI version, which is the same thing that I just downloaded from their website. So how this works is if we do Winget download and then the ID of the app, which is google.chrome, this will download the app. It should go into your downloads folder, which it does, and I get this MSI file. It's named slightly different than what I just downloaded manually, but this is the MSI file that I'm going to be given. And so we use this downloaded file in the FFU process. We'll download this, we'll install it via silent installation command, and that's it. The installation will go through. Notice it didn't actually go into this folder because I ran this all manually. So manually, when you do it, it just goes into your downloads folder. So you'll see that we end up getting two files in our downloads folder. We have this YAML file, and then we get the MSI itself. The YAML file is interesting because this file is what actually gives you the silent installation commands. So if I open this file, just open it with Notepad, this is actually going to give me a lot of metadata about the app, but more interesting to us is what the silent install command is. And so we get silent here, and there's also silent with progress. And so we're going to pull the silent switch from the YAML file that comes with all these applications that we're downloading. So we'll combine all of that, and then that information all ends up getting added to the InstallAppsAndSysprep file. So this file, as it goes through the FFU process, this is dynamically being generated depending on the options that you select, whether you're downloading cumulative updates, whether you're downloading Defender, all those other things, plus the applications that you're downloading through Winget. Those things all come together to customize this file to tell the VM what to install when it needs to install things. Now, how do we get Chrome to actually install through this process? Well, we need to modify the JSON files. So if we go and we edit the JSON files, I personally like doing this in Visual Studio Code. And so if I switch out here and we open up code, and we take a look at one of those files. Whoops, just go open this up. So we'll take a look at the sample JSON because it's smaller. So as I showed earlier, you basically just come in here and add whatever applications that you want. So by default, we put Company Portal and we put Microsoft Teams in here. And we wanted to show a MS Store file and a Winget file because the IDs are different. You can tell the IDs are completely different because the ID for a store app is going to have this 9W or could have an XP delineator at the beginning of the string for the ID. You'll see like a 9, you see like some number or an XP. And so those are your store apps. The Winget apps from the Winget repository typically look like the vendor and then the name of the application. Most typically. There are some cases where that's not the case. And so for Chrome, what we would do is we would basically just call this Google Chrome, and then we would just put in google.chrome. That's if we didn't want Teams. If we wanted to keep Teams, then we'll just leave all that, and then we would just add another line here. So just copy this, throw a comma there, paste that, and then do the same thing. Let's do Google Chrome, and then google.chrome. And so by doing that, that'll download the file that we just saw me do through the manual process through Winget. Downloads the file, gets the YAML file as well, and then we read that and we modify our InstallAppsAndSysprep.cmd file. And so if we go back to, actually I'll just copy this and I'll add it. So let's go back to our VM. And so in this case, what I'm going to do is I'm going to take this JSON file, I'm going to edit this. Now I don't have code on this machine. So what I'll do is just, let's not do that, paste that there. And that looks like it's formatted right. We'll save this as applist.json and just make sure that we save as all files. And I'll close that out. And so now I've got this applist.json. So it's going to install Company Portal, it's going to install Google Chrome, it's going to install Microsoft Teams. And I've got Office. And in the installation that we did before, Office was included in that. And that installation, if you didn't notice, that installation has completed. We'll go over all of that later on. But this section of the presentation just goes over how we customize apps. And so application customization has been done at this point. And so now we're just going to wait and move on to the next step here. And we'll be talking about drivers next. Okay, so drivers. So I mentioned drivers can be handled in a couple of different ways. The first way is we service them into the FFU before deployment. But the other way is to do this after the FFU is deployed to a device. And then we service the drivers after the FFU is laid down. Now the first option is best if you're imaging just one model. The FFU deployment is going to be much faster, and your driver store is going to be much smaller. Because if you add a whole bunch of drivers into an FFU, it's going to make it really big. And then the driver store on disk is going to be really large as well. And so you're going to be eating up just a bunch of disk space with drivers that don't really affect the device you're deploying to. So it's always best to just include the drivers for the model that you're trying to create the FFU for. But if you are managing different models, then we can add drivers after the FFU is laid down, and then depending on the model, we can go ahead and just copy in the drivers that you need in real time during the deployment. So the second option is best if you're imaging multiples, as I just mentioned, but it's going to make the deployment time longer because we are in real time using DISM to add drivers to that machine that you're currently imaging. So if time is of the essence and you want things to go really fast, then you're probably not going to want to select what drivers to install or do them at deploy time. You would probably want to have those drivers built into the FFU. Now in 2406, we introduced a new feature to automatically download the latest drivers from the major OEMs. And so how this all works is it leverages a number of different parameters during your installation command line when you're trying to run the script. And we have install drivers. And so the two parameters to understand and how they work is install drivers and copy drivers. Install drivers installs the drivers to the FFU. Copy drivers will copy the drivers to the USB drive. And then when it comes time to deploy, the USB drive will prompt you for which drivers you want to select if there are multiple folders found for each different model. If there's only one model that's copied to the USB drive, then we don't prompt you at all. We just assume that those are the drivers you want to use, and we just copy them to the FFU, or rather, we copy them to the device via the USB drive as you're deploying the FFU. Now, we've recently added copy PE drivers, and copy PE drivers will copy the PE drivers to your WinPE deployment media. By default, this is false. In most cases, you probably don't need PE drivers. They typically, at least in my testing for the number of devices that I've done, I haven't really had to copy PE drivers in. I do know, though, that there are some folks that have needed to do this for storage reasons. You may not necessarily need them for networking reasons because you're not booting from PE to WDS or to Config Manager or MDT. And so if you're not booting to some other source over the network, then you don't necessarily need those drivers in PE. But you may need them for storage. You may need them even for touchpad. If there's something that you want to do when you're in PE and you need like touchpad or keyboard drivers, you may need to add them there. But I haven't really found a need for that unless I've got multiple drivers or things where the FFU process is prompting me to select something, or if I type in a device name. In those cases, if I don't have keyboard driver, it's not going to work. So you may need to copy PE drivers from that. Now, for the stuff that we added in 2406 to automatically download drivers, we added make and model. So you'll type in a make, and if the valid values for this are Microsoft, Dell, HP, and Lenovo. And then for the model, this is just a string that doesn't have to be the exact model name. We're going to talk more about this later. But we use model to basically search for the drivers for whatever it is that you want to image. It doesn't have to be the exact model, although if it is the exact model, it's going to make your life a lot easier. And we're going to talk a lot about that here in the upcoming slides. We have drivers folder, which is just the location of where you want the drivers to be downloaded to, or the location of where you wish the drivers that you wish to be added to the FFU. So it doesn't have to be C FFU development and drivers. It could be whatever location that you currently have the drivers stored. It could be off of a network share, it could be local on the server, just in some other location. I personally just keep everything in FFU development / drivers. And we have cleanup drivers. So this just basically cleans up all the drivers inside of the drivers folder. Just because my whole goal with this is to not create a mess on your systems. So we try to clean up as best as we can and make sure that at the end of all of this, that your FFU development share or folder is completely clean. However, you can keep things around if you want, and so you can control that through the cleanup drivers parameter. If you set that to false, then your old drivers will stick around. And then Windows release, Windows version, Windows architecture, all of those I've talked about already, but those are important for drivers because some of the vendors require the Windows release, the Windows version, or the architecture, so we know what drivers to download. Okay, so automatically downloading. So we support the 4 major OEMs, support Microsoft, Dell, Lenovo, and HP. Now you must specify make, model, and either install drivers or copy drivers parameters. So you don't do both install drivers or copy drivers, you do one or the other. And then based on all of that, we'll then download your drivers and apply them to the FFU or copy them over to the USB drive. Each OEM will use some combination of Windows architecture, Windows release, and Windows version parameters, as I mentioned earlier. We only download for a single model. So you can't go and say, I want to download like 10 different models and we'll download all of them to a folder. You'll have to do that separately as you create each FFU. Wasn't designed for that. Could we perhaps make a helper function or a helper script that just downloads drivers? Sure, we could definitely do that. We have the code for it. We just have to move the functions around and create a separate PowerShell script. But the code's all there already. So if you want to do it, or if you need us to do it, we can definitely look at doing something like that. But right now, it's only going to download for single model. We'll most likely prompt you for additional info unless you're passing the exact model name. And most of the time, you don't know the exact model name because the model names that the vendor uses are probably completely different from what you're expecting. And so you're probably going to get prompted and say, hey, you typed in like a Lenovo 500W, but on Lenovo's side, they use this thing called machine type. And 500W, we don't understand that, but we understand machine type. What is the machine type that you're trying to use? Here are the different machine type values that you can use for a Lenovo 500W. Okay, so let's talk about Surface first. So with Microsoft Surface, the following command line says that we want to download the drivers for a Microsoft Laptop Go for Windows 10. Now, Microsoft Laptop Go does not exist. That's not a product. But you might just think, hey, I've just bought a bunch of Laptop Go's. I just wanted to go download those drivers. And so you use this exact command, and this is what happens. Well, before we get to that, the issue is that Laptop Go doesn't exist, and you probably purchased a Surface Laptop Go 3. And if you typed that in for the model, if Surface Laptop Go 3, if Laptop Go 3, or Surface Laptop Go 3, if that was the model that you specified, then you wouldn't have been prompted. And so in this case, when we look at what happens when you just use the command as is, you get prompted for all of the different models that are out there from Surface. There's only 44. I think now it's more because we just added the Pro 11 and the Laptop Go, or the Laptop 7. So it should be up to 46 now. But there's not that many Surface devices compared to HP, Lenovo, and Dell. They've got so many more models. And so we just list all of the different models for you. And you just pick from the list which one you want. So in this case, what you would want is you would want to select the Laptop Go 3, Surface Laptop Go 3, number 18. So you type in 18, and then it'd start downloading those drivers. Now for Dell, process is slightly different, but very similar. So the command line here says that we want to download Dell 3190 drivers for Windows 10. And so in this case, we have the make is Dell, model is 3190, Windows release is 10. Now, unlike Microsoft, Dell does not provide a pick list if the model isn't an exact match. And this is because Dell has this catalog XML file, and that lists the drivers. And the drivers are treated as primarily elements inside of that XML file. And so what it does is it lists what models the drivers can be installed on. And so what the script does is the script is doing some partial matching based on the model, and then it looks up, okay, if we find the model, let me find the driver that is associated with this. And so what we also do is we strip out firmware and non-driver types. It may include multiple video and audio drivers. We strip out old video and audio drivers, so we try to get the most up-to-date ones. However, some models ship with different video and audio adapters. So you might have a choice of buying a dedicated GPU on a device, or you might just want to use the integrated GPU. In those cases, you get options for different things you can purchase. But how Dell treats this is that they just provide you with all of the drivers, and you have to pick which ones you want. To automate this, we really can't do that unless we prompt you for every little thing, but then it kind of takes away a lot of the automation. So we might download a driver for video, which I understand is quite big sometimes. That might take up some additional space, but I'm banking on that most people don't care that if we download a little bit of extra drivers, as long as we're not like bloating your driver store completely out of whack. So it's like 4 gigs of drivers for all sorts of things that you don't care about. So you might have a driver or two here that don't actually match what is on your hardware. That's totally fine in most cases. So if we use that command that we showed earlier, this is what we'll see on screen. We see that we've downloaded the XML, where we expand it, and then we start to look through that XML file for your model. And then we start to download the drivers that are related to that model. And so the best thing we could do here is we do partial matching. And this actually does work fairly well. I haven't had any problems with the Dell devices that I've had to download. I've looked through all of the different folders, and things look pretty well. However, if Dell is your primary vendor that you use and you find that we're not matching right, fill out an issue, let me know what's going on there, and I'll happily take a look. Okay, so with Lenovo, so like I mentioned earlier, Lenovo doesn't use model numbers like other OEMs do. They prefer to use machine types. And so the machine type can be found on the bottom of your device as the first 4 characters of the MTM. I'm assuming that is machine type. I don't know what the M is. Maybe it's a model or some other value. But you should see something on the bottom of your device that says MTM : and then there's this long string. It looks kind of like a serial number. The script allows you to pass either the model or the machine type in the model parameter. So you can pass like a 500W, or you can pass the 4-character machine type. If passing the machine type, which would be model, and then for me, a 500W would be A2VR, you won't be prompted to select the current model. So if you match the exact machine type, then no prompting is done at all for you. So in this example, we do something very similar to the other ones, where we're looking for a Lenovo 500W, and we're doing Windows Release 10. And so in this case, what happens is we get prompted for picking the correct machine type. So in this case, I want number 4. And so the machine type value is the number in parentheses. And so as I mentioned, I want number 4 because that's what my MTM value looks like on the bottom of my device. And then when I do that, it's going to start to download all the different drivers for all of the hardware. And now with HP, again, very similar process. What's different here, though, is that we're including the Windows version parameter. So in this case, -Windows version 22H2. And we need to do this because this is what HP requires. In order for us to download the correct files, we need to pass what version we want to use. So we do that, and in this case, what I want to do is I want to download drivers for an HP X360. So with the HP X360, there are 40 different models that include X360 in the name. Now, unlike Surface, HP has hundreds or thousands of different models because they use this generation concept, which we kind of do the same thing on Surface as well, because we have the different, we have Surface Laptop 1, 2, 3, 4, 5, 6, 7. Same thing with Pro. And so we just increase the number. And so HP does something very similar, but they use X360 in a lot of different product lines as well. And so they have so many different X360s that are out there. So they have hundreds or thousands of devices that you could download drivers for. So what we do is we basically find anything that says X360, and then we just filter on that and give you a much shorter list to pick from. Now for me, I want number 25. Number 25 is the ProBook X360 11 G7 Education Edition notebook. That's one of the devices I have. Now, if I would have put model HP ProBook X360 11 G7 Education Edition Notebook PC, then the script wouldn't prompt me to select which model to download. So as you can understand, the vendor uses a model that might be different than what you think in your head. Because you say, oh, I've just got an X360. Well, yeah, but which of the 40 X360s do you have? And so if you pass the exact string match, then we don't need to prompt you because you've given us exactly what we're looking for. So we do that. We go download the drivers just like we do with all the other platforms, and we save them into the FFU development drivers HP folder. And then underneath that, the model number. Okay, now for manual drivers, to manually add your drivers, very simple. Just go to the FFU development drivers folder, and inside of that folder, create a new folder for the model that you want to add. Now, if using install drivers is true, then the drivers will be serviced directly into your FFU. If you add multiple driver models to the drivers folder, don't use -install drivers true. Use copy drivers true. And again, I mentioned the reasons why you want to do that earlier. It's going to copy the drivers to the deploy partition of the USB drive, and then it'll allow you to select which drivers you want to install during deployment. So it's going to keep your FFU file size small and prevent the driver store from being bloated. And if you need to add PE drivers, you can do that, as I mentioned earlier, under FFU development PE drivers folder. But you'll also want to say copy PE drivers and set that to true. If you don't set that to true, then those drivers don't get added to your Windows PE media. Okay, so let's start the demo of drivers. Okay, so for drivers, we've got a Lenovo 300W Yoga Gen 4 that I've got drivers on a different machine, and so I want to just bring these over. These are my own drivers. I'm not using the built-in process to do it. So if I want to add those, I would just copy, and then I would paste them into this drivers folder here in my FFU development drivers folder. And so this is going to take some time because it's doing it all over RDP. So there's some latency when doing it over RDP versus over the network. But the idea is pretty straightforward. Just copy in your folder of the drivers that you want. I'm going to cancel this because I don't want to sit here and wait for 5 minutes. But once you've got all your drivers, just copy them into here. And if we're going to use install drivers, then this would install just these drivers into the FFU file. If we were using copy drivers, this would copy the drivers to our USB drive. So in this case, we've manually copied our drivers in. Now let's take a look at what the make and model automated driver process looks like. Okay, so now with our previous deployment, we'd actually used this command here, where it says that we're installing Pro, we're installing our apps, we're installing Office, but install drivers set to false, because at the time I didn't have any drivers that I wanted to use, and I hadn't explained how the make and model stuff worked yet. So what I want to do now is I want to include make and model. Now, where you want to put this is actually kind of important because we do some parameter validation to make sure that drivers actually exist. And if the drivers don't exist, if you're saying install drivers is true, which is what we want to do, we want to say install these drivers into the FFU, so we want to make that true. But if you put the make and model after install drivers, if you did make, and then you put Lenovo, and then you did model, and put 500W, if you did this, you're going to get an error message. Because install driver is set to true, but either the drivers folder is missing or empty. And while it's true that the drivers folder is empty, there isn't anything inside of it. There's just a git keep file in there. It's actually not, the message you get isn't really clear. What it really means is that we need to take the make and model, we need to put it in front of install drivers. So how you want to do this is we'll take all of this out. And we'll go right in front of it to make and then model. And then by doing that, that will get the script to successfully run. And so here we see exactly what we showed earlier, that we have the 500W, there's 4 different machine types to choose from. I want to choose number 2. It's different. The list is a little bit different than we saw in the screenshot, but it's still the same list. It's just in a different order. So we hit 2, and then now we're going to go out and we're going to download the drivers. And so in this case, what we see is that we're going, I'm actually going to just stop it. Actually, I guess that's very interesting. Terminal doesn't let you pause, but PowerShell does. So what I wanted to show here is that we go out and we download, there's a bunch of catalog files for every single model that Lenovo has. And so we download this XML catalog file. And then inside of that, every single driver has its own XML file. And that XML file has a bunch of metadata about all of the drivers. And so we go and we look at the XML file, we find the download location of the file that we want to download, and then we save that appropriately. And so when we look at the drivers folder, it's much easier just to look at this than what the script is writing. But when we look in the drivers folder, this is where we can see exactly what's being downloaded. And we put everything into categories, make it really easy for you to see what has been downloaded. And so you can just go kind of poke through here if you want, just to see, just to validate that things are downloading. And so in our case, it definitely is. We see a bunch of files in here, a bunch of different folders. So so that's how we handle how we handle drivers. I'm not going to show each model or each manufacturer. The process is very similar for all of them. You just might get prompted for something different, and there's might be some implementation details on how we handle their files. But for the vast majority, it's all pretty much the same kind of process. You'll just see the model, the manufacturer, the make, then you'll see the model, and then all the drivers will be underneath it. Okay, so let's talk about customizing the USB drive now. Let's go over multi-model support for USB drive. So for the drivers, on the deploy partition, it's really simple. We just want to create a folder named drivers. And then inside of that folder, we'll create a subfolder for each model that you need to deploy. So this is only if you want to add your own drivers manually. If you want the script to do it, then the script will go ahead and copy the drivers in for you. So if you're doing this manually, create a folder on the USB drive on the deploy partition called drivers. Inside, put the model. And then when deploying, if we find that there are multiple folders under the drivers folder, so let's say we had like an HP folder, a Lenovo folder, or let's say you had a Lenovo 300W, you had a Lenovo 500W, so you had 2 different folders underneath the drivers folder. The script's going to prompt you to select which model. So in our example here, we have a deploy partition. We made a folder called drivers, and we have a Dell 3190 and a Surface Laptop Go. And inside of that, all the drivers exist. Now, when you go to deploy the USB drive is going to detect that there are 2 folders inside of that, and will ask you which drivers you want to install. And so you just hit which number you want, and then DISM will go ahead and copy the drivers into the Windows installation. Okay, let's go over device naming next. So with device naming can be done while in Windows PE. And how we do this is we leverage an Unattend.xml file. And inside of that, we can set the name at imaging time before we get to UBI. Now, the benefits of doing this is that with device rename during UBI, it requires a reboot. So what we can do is, instead of doing device rename during UBI through a provisioning package or doing it through Autopilot, we can do this during the imaging process via an Unattend.xml. And so this is going to save us some time by eliminating the need to reboot. It also reduces the number of provisioning packages or Autopilot profiles. A ton of customers have multiple provisioning packages just for device rename. Or they have Autopilot profiles for the exact same reason. Just all they're doing is just they have a different name template for whatever group of devices they're targeting their Autopilot profile to. So if using a provisioning package or Autopilot, we don't want to specify the device name or name template as it will overwrite whatever is set via the unattend method. And the unattend can also be used for additional device customization during the specialized phase. So if you want to run a separate command, if you want to run like an asynchronous command during specialize, as we're going through and we're installing Windows and it's getting itself ready, if you want to run additional commands, you can do that as well inside of the unattend. We primarily use the unattend just for naming, but you can do other things as well. So how this all works is that inside of the FFU development unattend folder, there are 3 files. There's a prefixes.txt, and then there are 2 unattend_architecture.xml files, one for ARM64, the other for x64. The prefixes.txt file can be customized to include whatever name prefix you want to use to name your devices. The script will append the serial number of the device to the end of the prefix. And when building the FFU, you want to use copy unattend true and the script will then copy the files to the deploy partition of the USB drive. Now, depending on the architecture, it'll rename the unattend_architecture.xml to Unattend.xml when copying to the USB drive. So you don't have to worry about getting the correct architecture type. We actually leverage the Windows architecture parameter to set this. And that defaults to x64. Now, if no prefixes.txt file exists, then the user will be prompted to enter device name. And if a single prefix is defined, then there is no prompt. We just assume that that's what you want, and we just go. So in your prefixes.txt file, you can have a file that looks very similar to this. You can just put whatever your prefix is with a dash. So in this case, we do 1, 2, 3, 4, or 5, 6, 7, 8. We put a dash, and then it'll just be the serial number. Or we can do ABCD, WXYZ. Any of these things can work. If you want to customize how this, like if you don't want to use serial number, you want to use something else, you'd have to modify the code of the script. We don't give you different options like serial number, or random number, or asset tag, or any of those kinds of things. If you want to customize it, feel free to do it inside of the script itself. But we just only use serial number to append to whatever the prefix is you've added here. And so the way that this works and what this looks like is that when it comes to deployment time, if you do not provide a prefix at all, then we prompt you to enter device name. And so in this case, I'm entering stu-my-laptop. That's the device name that I am going to use for this machine. However, if you have defined prefixes, then the device name prefix will show up in a list if you've got multiples that are there. So in this case, we have ABC dash, we have 1, 2, 3 dash. And so you just pick which of those you want, and then we'll append the serial number, and that'll be the name of the device. Now, if you want to customize the unattend to include more than the device name, then you can also add in the different components that you want to include in your unattend. And so in this case, we are including a component of Microsoft Windows deployment, and underneath that, there is a run asynchronous element that we have created. And so in this case, what we're doing is basically we're just setting we're running a CMD file or a CMD command to set the date of the machine. So in this case, we're setting it to May 31st, 2022. Now you could run multiple asynchronous commands if you want, and you can just add them to the list, or whatever else you want to do with unattend. It should work if you want to do that. Okay, next we'll talk about device enrollment. So device enrollment, there are 3 methods of enrollment. We have Autopilot, we have provisioning packages, and we have Autopilot for existing devices, which as of today, I do not recommend using. I'm not going to remove any of the code. If you're still using it today, you can still do that. But Autopilot for existing devices, as a company, Microsoft is making some changes to this, or is already in the process of making these changes. So AP for existing devices is going to be blocked if personal device enrollment is set to blocked for all customers on or after September 5th, 2024. For some customers, this is actually already set today. So what this means is that Autopilot for existing devices used to be a method where a device would be flagged as corporate instead of personal when in use. And so if you were using this and your devices were all corporate enrolled, there really wasn't any security boundary aside from the user that was enrolling the device. But if someone's credentials got compromised, then they wouldn't be able to enroll anymore. Or I'm sorry, they would be able to enroll devices as corporate devices. So if an attacker got someone's credentials, they're now enrolling these devices as corporate. It can cause some problems for that. And so for security reasons, we're actually making a change here to block these devices if personal device enrollment is set, because we actually are now changing this to personal device enrollment as opposed to corporate device enrollment. So if you're using Autopilot for existing devices, they are now going to be personal enrollments. And so if you are blocking personal enrollments, then AP for existing devices is not going to work. And so this is, for some customers, this has already started to happen. But for others, this hasn't happened yet. So September 5th, 2024, that's going to be when this is going to be applied for all customers. And so at that moment, you'll want to make some adjustments here. So if you want to use AP for existing devices, you will need to register the device or use Windows corporate identifiers. Corporate identifiers were just recently released, and this is essentially the tuple. So if you aren't familiar with what the tuple is make, model, serial number. You would upload a CSV of that information as a Windows corporate identifier. And if a device tries to register through AP for existing devices and they are in the Windows corporate identifiers, and we see that serial number is there, then that device can be flagged as corporate. Because that means you as the IT admin had registered these devices into your tenant. This does not require the Autopilot hardware hash, but you can use that as well. If you register a device as a Autopilot device with the hardware hash information, whether you do that or your partner does that, your OEM does that, then you could still use AP for existing devices, and those devices will come in as corporate enrolled. Now, if you still want to leverage AP for existing devices, the build deploy FFU.doc, that file has more information on how to do this. I'm not spending any time in this presentation explaining how to actually do this. Okay, so for Autopilot, regular Autopilot, not AP for existing devices, all Autopilot methods, user-driven, self-deploying, pre-provisioning, they all work with FFU. Now, my personal recommendation is to use self-deploying. The benefits to doing this is that there's no primary user assigned. What this means is that the company portal app can work for all users who sign into the device. There is no user necessary to enroll. So if you have Ethernet plugged into the machine, then the device is going to enroll right away. We don't have to wait for someone to type in a username or password. We just automatically start to enroll the device. So enrollment is fast. Now the downsides to this are that there is no primary user. So that's a benefit, but it's also a downside. Because some customers like having a primary user associated with the device. They like going into the Intune portal and seeing the primary user that's associated with it. But oftentimes what happens with primary users is that the primary user that's flagged in the system in Intune isn't necessarily the user that's actually using the device today. Sometimes that could be an IT admin. That could be a site technician. But it's not always going to be the person that is actually using the device right now. So the primary user by itself isn't necessarily a good way of identifying who actually owns or is using the machine. Now the other downside of this is that users can't do self-service actions. So BitLocker recovery keys are very popular these days, and recovering these keys, you can't do that if you're using self-deploying. As a user, you can't go and retrieve your own key. Now, some people don't know this, but there is a website, myaccount.microsoft.com, that an end user can go to, and that's where they can self-service a number of things with their Microsoft corporate Entra ID account. One of those things is they can go there and they can get their BitLocker recovery key. You can also do it now through the company portal app, and there are other ways that the key can be retrieved, either through IT, either through the Intune portal or through the Entra ID portal. But the user themselves can't do these actions. So they can't do BitLocker. They also can't wipe, reset, or rename the device. Now, most customers that I talk to, this actually isn't that big of a deal, because they would rather have the customer or the end user contact the help desk and retrieve the BitLocker recovery key. And so to me, this isn't necessarily a blocker to using something like self-deploying. I think the benefits of self-deploying outweigh the negatives, but that's going to be up to you and your environment and how you handle BitLocker recovery key retrieval, because that's the thing that's going to most likely incur a help desk call. And if your help desk is getting inundated with BitLocker recovery key tickets, then that's going to be probably a problem that you may not want to deal with, and you might want to have the end users do that themselves. And so my guidance here is that feel free to use whichever method of autopilot that works for you, whether it's self-deploying, user-driven, or pre-provisioning. This is just my own personal recommendation. Okay, let's talk about provisioning packages now. So provisioning packages aren't widely used across the board, but this is something that I used to recommend quite a bit before self-deploying got much, much better. And so in the FFU development PPKG folder, you can copy any .ppkg files that you want to use. So if you have provisioning packages that you've already made, take those packages, copy them into that ppkg folder. And then you'll use the -copy ppkg true parameter. By setting that, we will copy whatever provisioning packages we find in this folder to the deployment drive on your USB stick. Now you can also manually create the ppkg folder on the deploy partition and then copy them in yourself if you don't have the script automated for you. Very similar to drivers. You can always just copy in the drivers to the drivers folder on your USB drive. You don't have to have the script do all of the work. You can manually do that as well. And if using device naming via Unattend, do not set the computer name in the provisioning package, because the provisioning package is going to overwrite the computer name that you've specified in the device naming via the Unattend. Now, if you have multiple provisioning packages in the ppkg folder, the script is going to prompt you to select one at deployment time. So we're not going to prompt you while you're building the FFU and doing all that on your VM host. We're not going to do any of that kind of stuff. But it's when we plug the USB drive in and we see that we have multiple provisioning packages, if we see there's more than one, we're going to ask you which provisioning package do you want to use. Very similar to drivers. If we see multiple driver folders, we're going to ask you which one of these drivers, which model do you want to deploy the drivers for. So in our example here, we have the H drive for our deploy partition, and we have ppkg, and we see we have two provisioning packages. We have school A and school B. When we plug in our USB drive and we go through the process, we see both of these and we ask you, which provisioning package do you want to use? Just hit the number and we'll go through. Okay, now let's talk about custom Windows RE. So this is very simple. We don't have any automated support for custom Windows RE. What this means is that we're not actually going to build you a custom WinRE based on files and everything else that you pass and provide. We're not going to do that. I know some customers like to take the Dart tools. They'll take those and they'll add them to their WinRE. We won't be doing any of that. We aren't going to do any drivers. We're not going to do, and there's nothing in here that adds custom support for WinRE when building your FFU. But if you have a custom WinRE that you've already built, you can create a WinRE folder on your deploy partition, and you can copy that WinRE win to that folder. So you might have drivers that you're including in your WinRE, because you might have a device that mouse and keyboard doesn't work in WinRE because there aren't any drivers in the WinRE WIM for it. And so if that's the case, you need to add them to your WinRE. And so this is why we built this, this functionality with the USB drive. So on your USB drive, make that WinRE folder, copy the WinRE file into it. Pretty straightforward. And I just mentioned if you don't have the inbox drivers, things, keyboard, touchpad, storage, network, all that stuff may not work. So you need to add those to your WinRE. Now, what the script does do is it does handle the creation of WinRE, and it sizes it at 1 gig and places it as the 4th partition. So WinRE has been a very hot topic over the last year or so, with a number of cumulative updates that have had to go into WinRE. What we found is a lot of customers don't have WinRE at the last partition. A lot of that's our fault because of the guidance that we've given in the past. We've even had scripts that we have published on our Windows OEM hardware site that showed you want to put WinRE at like either the 1st or the 2nd partition. And so having it there makes it much more difficult to manage and patch it and extend it. And there's all sorts of things that have caused some customers problems recently. And so what we do in our process here is that we are going by the updated guidance to put WinRE at the end of the partition, or at the last partition, and then we're sizing it at 1 gig. The sizing in the past has been about 250, 300 megs. That's very, very small these days. 1 gig seems to be about the size now that I think that's what our recommendation is nowadays. But this has changed over the years, and so the size of the partition now should be large enough. But because it's at the end of the partition, at the end of all the partitions, if Windows needs to automatically service it, it can do that now because it's the last partition. And the custom WinRE is only necessary if you need it. So we've got WinRE as the folder, and then inside of that we have our winre.win. That's exactly what you would want. Okay, so now let's put all of this together. Okay, so let's go ahead and put everything together and run an end-to-end deployment. So the first thing that we're going to do is go over just what the command line that we have on the screen here looks like. It's very similar to what we did in the quick start demo, but there are some slight differences. So the first thing we're going to look at is our SKU. It's Windows Pro. It's no change from the quick start. We're downloading the media from the media creation tool. We'll use the ESD file from that. Our install apps is set to true, and install office is set to true. So we're going to create the VM, we're going to boot into it, and we're going to install all of the applications. We have a make of Lenovo and a model of 500W. We saw what that process looked like earlier, and we have an install driver set to true. Our VM switch name is external, as it was before. Our VM host IP address has changed slightly. Create deployment media is set to true, and install or build USB drive is set to true as well. We have our update latest CU, we have our update of the latest .NET cumulative update. We're also going to update to the latest Defender, update Edge, update OneDrive, and we're going to run this in verbose so we get all of the output to the console window. And then lastly, our logical sector size bytes value is set to 4096. And the reason we're doing this is because the Lenovo 500W is a UFS-based hard drive. That drive, because it's UFS-based, at least in my experience, all of these drives are 4K drives. And so because they're 4K drives, we have to specify a logical sector size bytes value of 4096. Most SSDs that are out there these days still operate with a 512 logical sector size bytes value. And that's what most people should stick with. That's what the default is in the script. But if you want to override what the default value is, you'll need to come and add the 4096 value if you have any hard drives that you're using that are 4K. So with that being said, we can go ahead and run the script now. All right, and so what we'll notice here is that we have to download our Lenovo drivers. And so we saw this earlier. So for me, I need to put a value of 2 in here, and that's going to download the 82VR machine type that I had downloaded before. And this process isn't any different than what we saw earlier with the Lenovo drivers that we had downloaded previously. So this is going to go ahead and log out everything that we're doing, and the FFU development log file, you can use that to track progress as well. So if the screen is moving too quick and you're finding it hard to follow, don't worry. All of the same stuff that you see on screen is being logged to this file as well. So you'll see all the driver download information. There are some slight differences, but for the most part, most of the stuff that you see on screen should be logged out here. That way, if you run into any problems, you can validate things are working the way you expect them to. Or if they're not working the way you expect them to and you need some help, you can always open an issue on the GitHub repo and attach this log, and I can take a look and see what's going on. Now, while this is going, it's going to take some time, so I'm going to go ahead and pause the video just so this video is not extremely long, and we'll come back when the drivers are done downloading, and I'll explain what's going on in the next phase. Okay, so now we're at the point where we're installing apps, but before we explain what this authentication window is, let's just kind of go back and take a look at what happened after the drivers were done downloading. So Lenovo finished its driver download, and then we validate that the ADK is installed. So in this case, we have the latest version of the ADK. If you don't have the latest version, we'll update you to the latest version. And we also have the latest PE add-on as well. So we validate both of those. If you watched the quick start video at the beginning, that video showed that we didn't have the latest version of the ADK or the WinPE add-on, so we downloaded both of those and installed them for you. The next step is to validate that, if install apps is set to true, then we'll go ahead and validate that the InstallAppsAndSysprep.cmd file exists. And so we see that it exists, and then we also take a look to see if the applist.json file is found as well. And so we see that, and so because of that, we need to check to see if Winget's installed. So we validate that Winget is installed, and we also check to see the applications are, or what applications are inside of the applist.json so we know which ones to download. So the first thing that we see is we have Microsoft Teams, and then we have a store app for Company Portal. So both of those applications will be downloaded, and then we validate if Winget is installed. And in my case, I have the Winget version 1.9 installed. You need, at minimum, version 1.8. 1.8 stable has the code that we need in order to download both store apps and Winget repository apps. And then we go through and we do the actual download of the content and create the appropriate folders for the content to go into. So we've downloaded Teams, and we are going to download the Company Portal app right now. Now, the Company Portal app is what's prompting me for credentials here. And the reason for this is because any application that is a store app that is flagged as the MS Store source, those applications must provide you must provide a Entra ID credential in order to download those apps. Now on my machine here, this machine's not joined to Entra ID, it's not hybrid joined. And because of that, it doesn't have a credential associated with the account that I'm signed in with. If I was signed in with an Entra ID, then Winget will use that credential and wouldn't prompt me for creds. So I'm going to type in my credentials here, and I'm going to get prompted. That's interesting. Okay, that was weird. I'm going to get prompted twice for credentials. And the reason I'm going to get prompted twice is because we get prompted once for the download of the application and its dependencies, but we then get prompted again for the license file. Okay, there's our prompt. Okay, so we've got the company portal, and now we're going to download Office. So we've downloaded the latest version of the Office Deployment Toolkit, and now we're going to download the latest current channel x64 build of Office. And this is about a 2.5, 3 gig download, so we'll wait for the download to finish. Oh, actually it finished really quick. So now we're moving on. So what you'll see here is there's a number of different things that we're downloading after that. It's kind of hard to follow it because there's so much that's going on right now. So if you find that you want to keep following and things are going a little too quick, just open up the FFU development log. If you have CM Trace from Config Manager, you can open the log with that. Formatting looks perfectly fine. And if you don't have this up full screen, you can see exactly what it's doing. And so in our case, we just downloaded Office in this area here. And then now we're downloading Defender. And so we get the latest Defender anti-malware definition file. We get the latest platform update and the security health platform update as well. And we go through and we download definition files and the OneDrive client and Microsoft Edge. And so if we go back to our PowerShell window, what we'll also notice is that we are creating an ISO file after we download Edge. So this ISO file is what we see right here. This ISO file is basically all the contents that are in the apps folder. So we take Defender, Edge, your store applications, in this case we have Company Portal Teams, Office, OneDrive, and then any Win32 applications that Winget downloads, which in this case we didn't have any Win32 apps. But if we did, we would see those applications listed there. And then we also see our InstallAppsAndSysprep.cmd file. This file has been modified, and we see all the installation commands for the applications that we're going to be installing. So if we go back to the PowerShell window, we'll then see that we are downloading, we've actually completed downloading our ESD file for Windows 11. We'll notice in here that if you look at this value right here, this is the date of the ESD file. this date is from December 4th, 2023. So this ESD is about 7 months old. And what we're doing right now is we're taking the ESD and we're adding it to a VHDX file. So we've created a VHDX, and that VHDX has 3 partitions. It's got our system partition, our MSR partition, and our OS partition. The OS partition is getting a drive letter map to W, and then we write the ESD file to that W partition. We also are adding we're setting the operating system up to be deployed as a compact OS. So this is to just save some space. If you don't like that behavior and you want to change it, you can. There's a compact OS parameter that you can set. So if it's -compact OS, if you set that to false, then compact OS is not set. We then also create a recovery drive. The recovery drive is about a gig. It's 993 megs is what it looks like it's set to here. And then we download the latest cumulative update for Windows 11 and the latest cumulative update for .NET. And so both of those downloads will be added to there's a KB folder here. And we then take those 2 KBs and we add them to the W drive, which is where we extracted the ESD file to for the VHDX. And so now we're going to service the media. And this process takes about 10 to 13 minutes, depending on how fast your machine is. We'll add both the .NET and the latest Windows cumulative update. And once that's done, then we'll start to boot into the VM and we'll start to install all of our apps. So I'll pause the video here because this is going to take about 10 to 13 minutes, and then we'll come back and take a look at what's going on next. Okay, so the cumulative updates have been installed, and now we're moving on to cleaning up the Windows side-by-sides folder. So this will take about 2-3 minutes or so, and then we'll move on to the next step. Okay, so we've completed the cleanup of the Windows side-by-sides. Now we're going to start doing a number of different things. The first thing you noticed is that the Hyper-V VM has been spun up. So we've created the VM, we've added the VHDX file, and we also create a FFU user account. You can see it here in the output. It's a standard user account, nothing special about it. It's got a randomized password, and that account is only used to copy the FFU from the VM to the host. And so we create a share, and once the whole process is done, we actually delete the share and we delete everything. So there's nothing that's left over after the process runs. And so I wouldn't be too concerned about the account. It's just a very simple account that all it's doing, again, is just copying the FFU from the VM. And at the same time, we're also creating WinPE capture media. The media or the way that we capture the FFU is we go into Windows PE, there's a PowerShell script that's run to do the capture, and then we capture it out, connect to the network, we use that user account that I mentioned, and then we copy the content in. So there's capture media that gets created, and you'll actually see that capture media right here. So this ISO will get mounted to the VM once the VM's complete and it's done installing apps and sysprepping and all that. And so what we'll see now is we're going to boot into audit mode, and this can take a little bit of time to boot in. Once we do boot in, we're going to automatically start running that InstallAppsAndSysprep.cmd file, and that has all of our installation commands for the applications that we want to run. So in this case, we're installing Office, and then we're going to move on and install all the other apps. And it's going to take a little while for Office to install. But in the meantime, though, you can actually poke around in here if you want, which also notices that we aren't connected to the internet. And the reason for that is primarily because I've seen issues with sysprep since even Windows 10. There have been issues with sysprep finishing successfully while connected to the internet with UWP apps. And so just to prevent those kinds of issues and to prevent the device going out and updating and installing things, we just hook the machine up to no internet at all, and we install all of our applications and then capture things like normal. And if you want to poke around, you can take a look. in the DVD drive, this is effectively just that entire apps folder that I mentioned earlier. So all the things that were in that apps folder, we put them into that ISO. That Apps.iso, this is what we're seeing right now. And if you do ever want to manually customize something in audit mode, you can put a pause in the install apps and sysprep file. Like I mentioned in the slide deck, we use the pause sometimes to troubleshoot, or if there's something that we need to manually customize, like the desktop wallpaper, or there's something you just can't automate. If there's any situation like that you cannot automate and you have to do it manually, then you'll want to put a pause in so you can make sure to give yourself some time to do whatever the customization is. We'll also notice now is Office, for the most part, is almost complete installing. We see Word, Excel, and PowerPoint here. It's just wrapping up its last few things, and then it's going to move on to the next step. So we've moved on, and now we're installing the Defender Update Platform. And so the Update Platform, the definitions, and then there's a Security Health app that's going to install after this. Those three things usually don't take all that long. And this gets you a completely up-to-date Windows Defender installation. We then go and install the OneDrive per machine setup. And we'll see that pop up here in a moment. You'll see an icon down here in the taskbar. And what we're doing with OneDrive is we're installing this as per machine. That's what you see, the /all-users switch. So that's what that's for. What this does for your users is if you have multiple users that sign onto a machine, we actually don't have to update OneDrive per user, which is what it does by default. And so anytime a user signs in, OneDrive has to update. And so what this is going to do is it's going to reinstall OneDrive, but it's going to make it a per machine install. And so anyone that signs onto the device will have the latest version of OneDrive available to them. We then install Edge Stable. And so that's fairly self-explanatory. We're just going to update Edge to the latest version of Edge so you don't have to go and download it when you sign into Windows for the first time. Okay, now we're going through and we're installing both Teams and the company portal app, and we do this via DISM. We leverage the add appx provision package commandlet to do that. And then we also go through and we delete out some of the Panther unattend files, and then we run disk cleanup. And so disk cleanup is just going to clean up any of the stuff that we just installed, any temporary internet files, Defender antivirus files, things of that sort. And then we sysprep. And so we're going to generalize the VM and the installation of Windows, and it's going to take about a minute or two. And once this is done, we will shut down the VM, and we will then boot to PE to do the capture. Okay, so the VM has been shut down, and we are now optimizing the volume that the VM is on. So we do some defrag work, some free space consolidation, and so this process doesn't take too long. But we do it to keep the FFU size small, because these FFUs are much bigger than WIM files, and so we don't want them to be too large, because we need to copy these large files to a USB drive and then ultimately to the hard disk. So the smaller the file, the quicker the deployment will be. And so what you're seeing now is we've booted into Windows PE with our capture media. And our capture media, inside of the capture media, we will mount the registry of the installed OS. And we do that to grab some values out of the registry in order to name the FFU file. And so that process takes some time, and what we've noticed while doing that is if we do things too quick, we find that sometimes capturing the FFU can fail. And so we have some built-in sleep activity. So in this case, we're sleeping for a minute to allow the registry to unload. We could probably shorten this to a little bit less, like maybe 30 seconds or something like that. But what we find is that a minute seems to be a good value here, and we don't see any errors with that amount of time. You'll also notice that there's another sleep that we do later when we optimize the FFU. And I don't recommend changing those values. Keep them as the defaults. These are tested and we know that they work. And so now that that's done, we are capturing the FFU. And so what this is doing is it's capturing the FFU back to your host VM. So the capture image process doesn't take all that long to do. But if you want to track where it's going, it goes to this FFU development folder /FFU. Inside there, that's where you can see the file and you can see that it's growing. So it's about 8 gigs now. Should be roughly about 10 to 11 gigs. Okay, and so we're done, and we see that the FFU is about 11.2 gigs. And it's pretty typical for what we had installed. We also copy in the DISM file from the VM from within Windows PE. So that's what this DISM log file is here. You can delete it, you don't need it, but just in case there's a failure or there's some weird thing that happens, I might ask for that if you open up an issue, or it's something you can look at if you want to check to see what's going on. Now back over here in the PowerShell window, that's where we see our VM is shut down, and then we check for the latest FFU file that was copied, and that's the FFU that we're going to optimize. And so optimizing the FFU allows us to deploy this FFU to any device. Because FFUs are sector-based copies of a disk, the sector size, or the hard disk size rather, that is important, because if we have a drive that we're trying to create an FFU from that's like 128 gigs, and we try to deploy that to a 64 gig disk, well, that's not going to work. And so we need to make sure that the FFU is optimized so that way it can be run on anything that we deploy to. And it works both ways too. So if we try to create an FFU from a 128 gig disk, but we have a 256 gig destination disk, we would only be able to use 128 gigs if we don't optimize. Because the FFU the hard drive that we copied from is only 128 gigs. And so because we're doing a sector-based copy, that's going to require, or it's going to limit us to only 128 gigs on whatever destination disk we have, whether it's 256 gigs or a terabyte disk, you will only see 128 gig max. So the optimization is important because the optimization is going to allow us to use this on any other drive. So we do a sleep for 2 minutes. We found that we were getting file handle locks if we didn't put any sort of sleep here. And so that's why that's there at that time. Again, I don't recommend changing that. We know that works. You can mess with it if you want, but if you start seeing any failures or any weird issues, I would go back and set it to about 2 minutes. And so then we do the optimization. The optimization of the FFU does take some time. So as we mentioned here, it's going to take a few minutes, so please be patient. Okay, so the optimization is done, and now we're doing some cleanup. So as I mentioned earlier, that FFU user account that we used to copy, we've cleaned that up. We've removed the virtual machine. The virtual machine is no longer there. And then we clean up a number of other things. Clean up the InstallAppsAndSysprep file. And now what we're doing is we're building your Windows PE deployment media, because the next phase of this is to build the USB drive. And so our USB drive is plugged into the machine, and we're just awaiting the PE media to be created. And then once we have the PE media, we can then take that and copy it, and we can format our USB stick, we can create the multiple partitions that we use, and then we can copy in the FFU file. So here you'll see that we're partitioning our USB drive. We have found that there's only one drive plugged into the machine. If I had a USB hub and I had like 20 USB sticks plugged in here, I can have it build 20 USB drives. Now it will take some time to do that because it's going to copy one after the other. It's doing it asynchronously. But the copy will work for multiple USB drives that are plugged in. And this process can take some time depending on how fast your USB drive is. And as I mentioned in the slide deck, we are adding in support for external hard disks. And the main reason for this is because there are some USB thumb drives. They look like thumb drives, but they operate as external disks. And for the longest time, I didn't want to do external disk support because I didn't want to accidentally delete any data or format or any of that kind of stuff with external disk that might be connected to a machine. Because you could have like a NAS, or you could have some really large external disk that had some pretty important data on it. And as long as we were using removable media, that's typically going to be fair game. But external hard disks, we try to avoid. So we are putting some checks and balances in that. And so that should be coming in the 2408 release in August. So we'll give this some time to copy, and then we'll come back when it's done. Now, I do want to call out one interesting behavior that you might notice if you have a 4K hard drive, like a UFS disk, is that you'll notice that it actually copies the drivers to the USB drive. And that's what you're seeing on the screen here as it's building the USB disk. It's actually copying the drivers to the deployment partition. And you'll notice this in the logging if you look at the very top of the FFU development log, that at the very top of this, we actually make a mention of this behavior is going to happen. So this is saying that logical sector size bytes is set to 4096, which is not supported for driver injection, setting install drivers to false. As a workaround, setting copy drivers to true to copy drivers to the deploy partition drivers folder. We are investigating this issue and will update the script if and when we have a fix. So the issue here is that when you make an FFU that has a logical sector size bytes value of 4096, when you try to inject drivers to that FFU via DISM, you'll actually get some error message that comes. I can't recall if it actually happens during the copy of the drivers or if it's during the deployment of the FFU later on, but regardless, you do end up getting some sort of error. And so what we've done to work around that is we just copy the drivers to the USB drive, and then we deploy them at deployment time. So you won't see this behavior if you have a logical sector byte size of 512, but you will see it if you have a 4096 value. And I still have to go through and talk with engineering to see if there's some sort of fix here that we can implement, or if this is even a known issue on their side. But it's just something that I've noticed. Okay, so the process is complete. We have copied all of our drivers in, we copied the FFU, we've now cleaned up a lot of our mess. And if we go and take a look at our FFU development, we see a fairly clean, we don't have drivers in here. Our apps, for the most part, are cleaned out. And everything looks like it's in a good place. So let's take a look at the USB drive. So you'll see these temp, at least on my machine, I see temp boot and temp deploy. When you plug this USB drive into the physical machine that you're going to be deploying to, you should see the drive names as boot and deploy. The deploy partition is where all the good stuff is going to be. So that's where your FFU is going to be, and then drivers. And if you did add the naming, so if you wanted to have an unattend file with the naming, then you would have that. You would see an unattend folder here. If you have provisioning packages, you would see the provisioning packages here. I see the drivers, as I mentioned, it automatically did that for me because of the issues that we have with 4K hard disks. But this looks good. This looks like something now I can take this USB stick in, I can go ahead and plug it into a machine. The next part of this is that we're going to go and take a look at what the deployment looks like. But I'm going to do that through a VM just because it makes it a lot easier and it's cleaner to see. So let's go take a look at what that is. Okay, so what some people have asked is, how do we use a VM to test the FFU before we try to deploy it to a physical device? Because FFUs, they can take a while to deploy on some machines if they're older hardware. And we just want to validate that the FFU that we just built works. And so what we've done recently is we've modified the deploy ISO to allow it to work both for VMs and for physical devices. And so you should be able to use your deployment ISO. There is a variable that you will need to set to maintain your deployment media. The variable is cleanup deploy ISO. You want to set that to false. So when you're running your command to build your FFU, set -cleanup deploy ISO to false, and your deploy ISO will stay in the C FFU development folder. You can then use that to boot to a Hyper-V VM if you want to test your FFU out. So what you're seeing here on my screen is I've got this VM that I built, and it has a number of SCSI devices. We've got our hard drive we're going to copy to, and we also have our DVD drive where we mount the deploy ISO to. And then we have this FFU source VHDX file. So what you'll want to do is create a blank VHDX, just create an empty VHDX file. And what we want to do is we want to copy our deploy partition content to that drive. And if we take a look at what mine looks like, this looks very similar to what the deploy partition should look like for some of you when you're creating your USB media. And if I look at the deploy partition of the drive I just built earlier, we see that I've got a drivers folder and I have my FFU. Now I don't need drivers for a VM. So in my FFU source VHDX, I put a 1 on the drivers folder because I don't need to see that for the deployment I'm about to do. I also have a provisioning package folder set to 1, and I have an unattend folder set to 1. I don't need these, however, I have them so I can show what the experience looks like. So when I'm doing a demo or if I'm creating a presentation like this, I can take some screenshots. And then we also have our FFU file as well, and then we see our script log and our DISM log. So this all looks just like what a deploy USB drive will look like when you're deploying this to a physical machine. One thing I'm also going to do in this demo is I'm actually going to take the 1 off of this so we can see what the provisioning package process looks like, because I'm going to need to use a provisioning package to enroll this VM that I'm about to build, because I can't use Autopilot self-deploy because it requires TPM at a station. So we'll see what this process looks like, but just know that on a VM, because we don't have access to physical USB media, we won't actually have the exact same experience as a physical device because of how VMs operate in this situation. So let's go ahead and run the VM now. Actually, let's double check one thing here. Okay, so we're booting from our USB or from our DVD drive. Also, just make sure to enable TPM as well when you're creating your VM. And should be good. Oh, you will get that error if you don't eject your media. So make sure to eject the media, and you should be able to boot. So we're going to boot from our ISO, and this is going to start the process, and it should prompt us for which provisioning package we want to use. So in this case, we hit 1. And this will apply the FFU after you select your provisioning package file that you want to use. And this process on a physical machine will take about 90 seconds to maybe a couple minutes, depending on how large your FFU is, and also depending on how fast your USB drive is and the hard disk that you are copying to. But it should be very, very fast. And that's the whole point, is that we can get through these machines very quick. And remember, this has Office in it, it has Teams, it has company portal. And so now Windows is going to go through and set itself up, and this takes a couple minutes to go through and get ready. And so we'll pause the video and we'll come back to it when it's done. Okay, so Windows is done setting up, and now we're ready to apply our provisioning package. Now, if you're on physical media, what you should have noticed is that the provisioning package would have automatically applied, because what we do is we copy that provisioning package out of the folder to the root of the USB drive on that deploy partition. And Windows will detect removable media, and it'll go ahead and apply. But in the situation that we're looking at right now, this VM is not using removable media. The VM, that VHDX that we have mounted, is just like a regular hard disk. And so Windows isn't going to apply that FFU, or I'm sorry, it's not going to apply that provisioning package to do the deployment. So what we need to do is we kind of need to work around that a little bit by using a ISO. So if we go click on Media and we go and mount our ISO, this ISO contains the exact same provisioning package that I selected. So if we hit the Windows key 5 times, we can select our provisioning package. And sometimes Ubi will do this where it'll restart. It doesn't always do it, but in some of the later builds of Windows, I've noticed this behavior. Yeah, it keeps going through this like restart. Let's try this one more time. There we go. So it's going to enroll us into Azure AD. It's going to apply policies. There really aren't any major policies here. We just basically take the defaults. The whole point of this is to really just get us into enrolled into Azure AD, very similar to what we would see with Autopilot self-deploying. The only challenge here is that because TPM attestation doesn't work on VMs, we can't use Autopilot self-deploying. Okay, and now we're done. So the device has now been enrolled. And it's going to take a few minutes for our policies to start to come down. Behind the scenes, Intune is deploying any policies that are targeted to my machine. One of those policies is my ability to sign in without passing in the UPN. I could just pass in my username. And when I see this sign-in change from your work or school account, it should change to my domain. And when I see that, then I know that the policies have come down to the point where I can start to sign in and I should start to see things happen on my desktop. So I'm going to give this just a minute and we'll come back. Okay, so we see the domain is here, so I can now just sign in with my username. It usually doesn't take too long. Usually it's about a couple minutes at most. And so now we'll let the user profile get created. This takes usually about 90 seconds. Okay, so we are now in the VM, and as you can see, we have Office, as we expected. And then if we go and look through the rest of the apps list, what you'll also see is Company Portal is here, and we also have Microsoft Teams. And Intune now is applying a bunch of different policies and settings that I have targeted to this machine as well. So it's already configured OneDrive. Again, this is the per machine install, and it has been configured with known folder move and silent configuration. So I didn't have to sign in or do anything with that. What we'll also notice in here is that if I go into Edge, we'll see that Edge is already been pre-configured. Again, Intune has already configured all this stuff for me, so I don't have to really do a whole lot. And Word, Excel, PowerPoint, all of those. One thing to know about how Office installs through the Office Deployment tool, and you probably have noticed this in your own environments too, is that the product key, you'll get prompted for this product key the first time you open it up. If you just close it, you can kind of already see that my name was already at the top there if you were quick and you saw that. If you close it and reopen it, activation is fine. So you don't have to worry about like, oh, we're getting prompted for this product key, we have to type in a product key. You don't have to do that. It's just the way that the installation of Office is with the Office Deployment Toolkit. You can bypass that. It's not a big deal. And if you look at your account, you'll see that your subscriptions do exist. Your subscription is valid. You're using Office Apps for Enterprise. And then you also see the build, which is 24/7, current channel. This is what we downloaded through the FFU process. And with all of that, that concludes the demo of the whole process. And next step, we'll take a look at troubleshooting and some just other miscellaneous things that you might want to be aware of. Actually, one thing I did want to call out is after the deployment on your USB drive, the script log file is the log that we use. It's just a text file that logs the application of the FFU drivers and everything else that goes into it. If you open this file, what you'll notice in here is that we time everything. Now, we also put in like what the device manufacturer is, the model, hard drive information. We check to see, are we running in a VM? Are we running as a physical disk or a physical device? And that stuff helps us when we try to boot from like a VM versus a physical disk. So there's some things that we're doing there when we take a look at the hardware info. But what you'll also notice here is that we have the FFU, that we found the FFU. We didn't see an Unattend folder. We didn't see an AP or an Autopilot folder. And we do see that we have 3 provisioning package files, and we selected our BlueEDU VM provisioning package. We then cleaned the disk, and we applied the FFU to the physical disk 0, effectively. And we then ran our command to apply the FFU. And what you'll notice, now remember, this FFU is about 11 to 12 gigs. It's fairly large. And we started at 11:42:19 a.m. and we started at 11:42:19 and then we completed at 11:42:42. So the deployment was less than 30 seconds to lay down the FFU itself. Then we had to do some copying, but in all, the whole process finished at 11:42:48. So copying the FFU and laying it down to disk, very, very quick. And again, remember, there's Office in here, there's Teams, and there's the company portal app. So that process was very fast. And so if you want to see how long your FFU deployments are taking, you can look at the script log text, and this is a good way to time exactly how long it takes to lay down to disk. Now, this doesn't include the booting to Windows. It doesn't include anything that you might be deploying with Intune. So that process is obviously going to take longer. But just to lay down the FFU, this took 30 seconds. Now remember, this is in a VM, so it's going to be faster than what you might see. In most cases, with lower end hardware, what I typically see is about 90 seconds to 2 minutes. So anything that's relatively new, you could probably get the FFU down in maybe a minute and a half. Okay, so let's move into troubleshooting. So troubleshooting, the biggest issue that I see people run into is with the Hyper-V switch configuration and not selecting the right IP address for the switch that they're using. So oftentimes someone will go in and grab the wrong IP address or maybe even the wrong switch name, and they don't get those right. So you want to make sure that when you go into IP config, make sure you're getting the correct switch and you're getting the correct IP address and validating that those are right. Now for logging, we've talked about logging throughout the presentation. When we create the FFU, it's under C, FFU development log. For the deployment of the FFU, it's under scriptlog.txt, and that's on your USB deploy partition. And the dism log is dism.log, as you know. So that will be copied over in a variety of different places, depending on which stage you're in deployment. That primarily helps me and you take a look at what potentially went wrong when deployment perhaps failed. If app downloads fail via Winget, you can try to manually download the app via Winget download app ID. This is typically how I troubleshoot, because sometimes maybe Winget's just down. You could have some network issues. But also, delivery optimization is a big part of Winget. We actually default to using delivery optimization. So check and see if delivery optimization is working in your environment. If DO does not work in your environment, there's something going on with your network, you will run into issues downloading applications through Winget. Now you can override this. Winget has its own set of settings, and this presentation isn't designed to go in depth on how Winget functions. But you can override the DO behavior and choose to just download directly from the internet, as opposed to leveraging DO to do the download. So that's one option that you might want to look into for your machine. But the script itself doesn't do any overriding of using delivery optimization. And if you have an issue, open an issue on the GitHub repo. So you can go to URL you see on the screen and open up an issue, and I'll take a look. Or there's a few folks from the community that also chime in on any issues that users bring up. So feel free to open an issue and let me know what's going on. And lastly, if you're in the education industry, my team runs a office hours twice a month. So the QR code that you see on the screen here, you can go ahead and hold your phone up to that, or you can go to aka.ms/edu endpoint office hours and register to get the Teams meeting invite for our biweekly sessions. And in these sessions, you learn from me and my team, our engineering teams, about all things endpoint management, whether that's Microsoft Intune, whether that's Azure Active Directory or Entra ID. We go deep. The stuff that you see here today, we've been talking about FFUs for a long time in that community, and we've been building and iterating on the process for a long time. And so now we're expanding this out to really any industry that wants to use it. FFU is fine for anyone to use. It doesn't have to just be education. But if you are in education, this community is for you. So if you're a small private school, if you're a large K-12 district, if you're an academic medical center, if you're a higher ed institution, all in the education industry are welcome. And I'd like to see you there on a future meeting. And with that, that's going to wrap up the presentation. Take care, and hopefully this helps with your imaging.